This is a short video for Lab 10, which is the review, and this is of course the review for the culminating lab, which is Lab 11. And when you walk into the Physics 261 lab, you should see that we've got one copy of each experiment set up in the lab. In fact, there'll be two copies of each experiment, and you'll be able to go around and move around the room and work on each one and answering questions for each one of the experiments that we did this semester. So let's just start. Here is experiment 2. You might be wondering, well, where did experiment 1 go? Experiment 1 was Excel, and of course you'll have to use Excel for answering some of the questions and doing analysis and plots. So experiment 2 was about uncertainty and measurement, and there were just these masses as well as a couple of screws, a small cylinder, and you had to use the calipers, digital calipers, and also a mass scale to make some measurements. Next lab was experiment number 3, which was about position, velocity, and acceleration. And for that, there was an air track and a cart, and you could tilt the cart by using a step lock and use the sonic ranger to measure the motion of the mass. Next experiment was momentum and drag. This is experiment number 4, and for that, again, there was an air track, and there were two carts. There was a cart B and cart A, and each one of those had picket fence on it and bumpers, and the idea was that you could pass them through two optical gates and measure the motion of each one of them. You could watch as the carts collided what happened as they went into and out of a collision. And there was also a mass scale, because the basic principle here is conservation of momentum. And also you did some experiments to determine drag in the system. There were some additional masses that you could use to drop into these carts to see how the momentum changed. Next experiment, which you can kind of hear running here, was the centripetal force apparatus. There was a motor on top that turned a gear that spins around this mass. If I go over, look, you used a web camera to keep track of what that mass was doing, and there was a controller on the side that allowed you to change the speed. In fact, you have this small knob on the edge here, on the end here, and that allowed you to change the rotation speed. The idea was you'd measure the response of the mass, or how much radius changed, the radius of motion changed as you changed the speed. That was, again, experiment 5, centripetal motion. Next experiment was a simple one, experiment number 6, the pendulum. And you can kind of see the apparatus here. There are actually two different pendulum, a metal one and a wood one, and an optical gate that was used to keep track of the period of the pendulum when the string, which holds the mass, moves through the optical gate. It would block a beam, and you could use that to keep track of how long it took for the pendulum to swing back and forth. And use this to measure G, the acceleration due to gravity. You get a couple of other things here, rulers, a square, and tape measure, and also this micrometer set, or digital calipers. Next experiment was experiment 7, which is forced harmonic motion. You can kind of see here. There's a couple of main parts to this. Obviously an air track and a cart with a reflector on it, and on one end is a sonic ranger which keeps track of the position of the cart, and on the other end there's a speaker which you can use to drive the motion of the cart, and the cart is attached by 2 springs here and has a resonance in it. If you drive it at just the right frequency using the speaker, you get a relatively large motion, and you control that motion by means of this function generator here on the side. And for example, this is now driving at about 1.29 hertz. You can actually just barely see the end of that speaker moving, whereas the motion of the cart is quite large compared to that drive motion. And that means that the cart is being driven pretty near resonance. So you measured that a couple weeks ago. And next experiment, or a few weeks ago, next experiment was the vibrating string, or waves on a string. This is experiment number 8. There's a long string with a shaft which you can change the rotation speed using the motor controller. And down at the other end of the string there's a pulley, and you can apply tension to the spring by putting mass onto the end of this weight holder. Of course, don't forget that you see total mass here that sets the tension of the spring, and that includes about 50 grams for that weight. And right now, the frequency of the shaft gears has been turned so that we're getting relatively large vibration, which is probably close to the fundamental mode for the string. Next experiment, this is experiment number 9, ideal gas law and absolute zero temperature. You did this probably a week before, and there's 2 parts to the apparatus. One part is just a pressure sensor and a syringe here, which allows you to measure pressure as a function of the volume of the space in the syringe. And the other apparatus has a bulb in it, which you can monitor the pressure of, and that bulb goes into a water mixer or into water which you can change the temperature of. There's a thermometer here. The idea is you can measure the pressure as a function of the temperature. So these are the Boyle's law and Charles' law apparatus, which you use for looking at ideal gases and determining absolute zero. And well, that's it for the review, or a quick look at the review. You'll be going through each one of these setups. You want to make sure that you review them because they'll be set up the following week also for the practical exam.